The migration was officially declared a success. Every application was running in Azure. The databases were available. Users could log in. The old data center was ready to be shut down. And there had been almost no major downtime. From a technical migration perspective, everything looked perfect. Then the first complete Azure bill arrived. It was not lower, it was not even close to the original estimate. The monthly infrastructure cost had almost doubled. Management asked the obvious question: wasn't the cloud supposed to save us money? The engineering team had successfully moved the company to Azure, but they had not actually transformed anything. They had taken the same servers, the same architecture, the same capacity assumptions, and the same operational problems, placed all of them inside someone else's data center. This is the lift and shift trap, and it is one of the biggest reasons cloud migrations disappoint businesses. Now, let us look at the original environment. The company had a traditional application running on premises. There were four virtual machines for the application, two more machines for background processing, a separate database server, another server for reporting, and several development and testing environments. Most of these machines had been sized years earlier. The production servers had enough capacity to survive the busiest period of the year. Development and test systems remained online almost all the time. Some servers were running at less than 20% utilization, but the infrastructure had already been purchased. Whether a server used 10% or 80% of its CPU, the company did not receive a new invoice every hour. Then the migration team performed a direct mapping. One on premises virtual machine became one Azure virtual machine. The database server became another Azure virtual machine. The test servers were recreated in Azure. The storage was moved, the network was rebuilt, everything looked familiar. That familiarity made the migration faster. It also carried every old inefficiency into a consumption based platform. In the cloud, every architectural decision has a meter attached to it. The virtual machines have a cost, managed disk have a cost, snapshots have a cost, backup storage has a cost, network gateways has a cost, monitoring and log ingestions have a cost, public IP addresses, private connectivity, outbound traffic, and support plans can all contribute to the bill. The company had estimated the cost of the major virtual machines, but it had not modeled the complete operating environment. More importantly, the company continued to size infrastructure as if it were buying physical servers. Every virtual machine was provisioned for peak capacity. Developer machines ran throughout the night. Test environments ran over the weekend. Old disks remained attached after applications were removed. Snapshots accumulated. Logs were collected without retention limits. Multiple teams created their own resources because there was no consistent governance model. None of these individual decisions look catastrophic, but cloud cost problems rarely come from one enormous mistake. They come from hundreds of small resources that nobody owns, nobody reviews, and nobody switches off. At this point, many teams conclude that Azure is simply too expensive. That is usually the wrong conclusion. Azure did exactly what the company asked it to do. The company asked for 16 virtual machines running 24 hours a day. Azure provided 16 virtual machines running 24 hours a day. The company asked for large disks, long log retention, multiple gateways, and permanently running non production environments. Azure provided all of them. The real problem was not cloud pricing. The real problem was that the architecture had been designed for a world where capacity was purchased in advance, but it was now being built in a world where consumption was measured continuously. The company had changed the location of its infrastructure. It had not changed how the infrastructure was designed, operated, or governed. Was lift and shift the wrong strategy? Not necessarily. This is where the discussion needs some honesty. Lift and shift is not automatically bad architecture. Sometimes an organization must leave a data center before a contract expires. Sometimes hardware support is ending. Sometimes a merger requires systems to be moved quickly. Sometimes the application is too old to modernize during the first migration. Sometimes the business cannot accept the risk of changing both the platform and the application simultaneously. In those situations, moving a virtual machine directly to Azure can be the fastest and lowest risk option. The mistake is failing to define what happens after rehosting. If the migration plan ends with everything is now running in Azure, then the organization has only completed the relocation phase. It has not completed the optimization or modernization phase. A successful migration needs two questions. First, how do we move this workload safely? And second, what should this workload eventually become? This is where companies need to stop treating the migration as one giant infrastructure project. Every workload should be assessed separately. Some applications should remain on virtual machines. A stable legacy application with predictable demand may not justify months of engineering effort just to become cloud native. Some applications should be replatformed. A web application running inside a manually maintained virtual machine may be moved to Azure App Service. The application changes very little, but the team no longer has to manage the operating system in the same way. Some workloads may be moved from a self managed database to a managed database service. The company still owns the data model and application, but Azure handles more of the underlying availability, patching, and platform operations. Some event driven or short running processes may be suitable for Azure functions. Some containerized applications may fit Azure Container Apps. More complex platforms that genuinely need Kubernetes capabilities may belong to AKS. Some systems should be refactored because their architecture prevents independent scaling or reliable deployment. Some systems should be replaced with software as a service. Some should remain where they are, and some should simply be retired. The goal is not to force every application into the newest Azure service. The goal is to select the operating model that produces the best balance of cost, reliability, delivery, speed, security, and engineering effort. There is another trap here. Teams hear that virtual machines are expensive, so they immediately decide to rebuild everything using microservices, Kubernetes, and serverless technologies. That can make the situation even worse. Modernization is not free. It consumes a lot of developer time. It introduces migration risk. It changes deployment process. It creates new security and observability requirements. And it can replace a simple expensive system with a complicated expensive system. Moving a small stable application from 3 virtual machines to 30 microservices on Kubernetes is not automatically an improvement. You may reduce one infrastructure cost while dramatically increase the cost of engineering, operations, and troubleshooting. The correct question is not what is the most cloud native architecture. The correct question is what is the simplest architecture that meets the business requirements. The company in our example also made another major mistake. It started migrating applications before establishing a proper Azure foundation. There was no clear subscription model. Production and non production resources were mixed together. Naming was inconsistent. Tags were optional. Budgets were added only after spending had already increased. Access was granted manually. Network designs were different across teams. Security policies were applied after deployment instead of being built into the environment. This is why an Azure landing zone matters. A landing zone is not simply a subscription with a virtual network, it is the operating foundation for Azure. It defines how subscriptions are organized, how identity and accesses are managed, how networking is structured, which policies are enforced, how security is monitored, how costs are allocated, and how application teams receive environments without rebuilding the platform differently every time. Without that foundation, cloud adoption becomes cloud sprawl. Imagine that every Azure resource must include four tags: application, environment, owner, cost center. Now, finance can identify which application generated the cost, engineering can identify which team owns the resource, automation can detect non production systems and switch them off outside working hours. Policies can prevent teams from deploying unapproved resource types or locations. Budgets can alert owners before spending becomes a surprise. Access can be assigned through groups and roles instead of individual permissions. Subscriptions can isolate production, non production, and sandbox workloads. These controls do not merely make the portal look organized, they change the economics and security of the entire platform. Cloud governance is not paperwork added after architecture. Cloud governance is architecture. So, what should the company do after discovering that the bill has doubled? It should not begin by randomly resizing virtual machines, and it should not immediately launch a 2 year modernization program. First, build a complete inventory. Identify every application, virtual machine, disk, database, network dependency, and owner. Second, measure actual utilization. Look at CPU, memory, storage performance, traffic patterns, and operating schedules over a meaningful period. Third, remove obvious waste. Delete abandoned resources. Detach and remove unused disk. Review snapshot and backup retention. Reduce unnecessary log collection. Stop non production environments when they are not needed. Right sizing machines using real evidence rather than historical assumptions. Fourth, choose a strategy for every workload. Retain, retire, rehost, replatform, refactor, re-architect, rebuild, or replace. Fifth, establish governance before migration continues. Create the management group and subscription structure, apply policies, define mandatory tags, set budgets and alerts. Standardize identity, networking, security, and monitoring. Finally, modernize only where the business case is clear. Start with the applications that have high operating cost, poor reliability, slow release cycles, or rapidly changing demand. Do not modernize merely because a service looks impressive on an architecture diagram. A cloud migration should not be declared successful just because every server is now running in Azure. That measures movement. It does not measure business value. A successful migration should answer more meaningful questions. Did infrastructure spending become visible and attributable? Can non production capacity scale down when it is not needed? Can teams deploy safely without waiting weeks for infrastructure? Did security and compliance improve? Can the application recover from failures? Can the workload scale when demand changes? Did operational effort decrease? Did the company close the data center or eliminate the cost it originally intended to remove? And most importantly, did the migration improve the company's ability to deliver and operate software? If the answer is no, the servers may have moved, but the organization has not adopted the cloud. The cloud is not automatically cheaper, it is not automatically more secure, and it is not automatically more reliable. Azure gives you the ability to consume infrastructure differently, but the financial and operational benefit appears only when the architecture, governance, and engineering practices change with it. Lift and shift can be a useful first step, but it should rarely be the entire journey. Because when you move an inefficient system to the cloud without changing anything else, you do not remove the inefficiency. You simply begin paying for it every hour. And that is how a technically successful Azure migration ends with a cloud bill that nobody expected.